I used a Nema34 stepper motor I bought on eBay by Auch Motor GmbH. These are the technical specifications for the motor. Then I used this stepper motor driver. Also available on eBay by Auch Motor GmbH. And I used this power supply I bought for my physics lectures on my homepage, PeakTech6070. The Arduino code is very simple. You can use an Arduino Nano or an Arduino Uno or an Arduino Mega, what you like. You only need 3 outputs. I used e.g. output 2, 3 and 4. Have the pulse, the direction and enable. The stepper motor, if you would use the stepper motor in full step mode, one step would be 1.8 degrees. And for the wave machine, I used an angle 180 degrees. So in full step mode, you have to do 100 steps. 100 multiplied with 1.8 gets 180. But with this driver, I used micro-stepping with 64 microsteps. So I multiplied 100 with 64 because of micro-stepping. 100 multiplied with 64 is the number of steps for 180 degrees. In the setup, you have to declare the pins 2, 3 and 4, also for pulse, direction and enable as outputs. And I initialized the pulse with low, the direction with high, and enabled also with high. And the loop tile is also very simple. You only have to set a pulse with high and then delay microseconds pause. I used for pause 112. You have to test it for your waterbed. I used a rope and pulled me up, and I stopped the time for 100 periods, and I tested 100 periods. Took a time about 5 minutes, and one period is for my waterbed 3 seconds, and 3 seconds is the resonance time, and so I wanted to get a period from 3 seconds, because then I'm in resonance for my waterbed. If you have another waterbed, maybe you don't need 3 seconds, maybe you need a little bit more or less, you can test it. But in my case, a period at a duration nearly from 3 seconds. If you like the project, you can support me by buying my mathematics or physics software on my homepage. Thank you very much. And if you have good ideas to improve the construction, maybe you can hang your stepper motor on with ropes instead of a platform. I haven't tested it to reduce noise. The connection is very simple. You have the DC plus and minus for the power supply and the A minus plus, B minus plus for the stepper motor. If you don't have the documentation of your motor and don't know what wire you have to connect for A plus, A minus, it doesn't matter. It's very simple. You have only 4 wires. And you take one of your 4 wires, and then you can measure the resistance between this one wire and one of the 3 others, and there will only one of the 3 others that the resistance is very low. And then you can say, well, one wire is, for example, A minus, the other A plus. The direction doesn't matter. If you change the directions, the stepper motor will turn in the other direction, but this doesn't mind. You can change the wires, or you can change the programming code by setting the direction instead of true false, or otherwise instead of false true. It's very simple. You can't do something wrong. You only have to take one wire and measure which of the 3 wires has a small resistance with the one wire you have chosen. And after you have done this, you know you have the 2 wires, A plus minus. The direction doesn't really matter. And the 2 wires left are B minus, B plus. The direction doesn't matter too. So the connection for the motor is simple. Then we have these ports. You can connect the plus 5 volt with your Arduino out 5 volt. And we have 3 output ports for the Arduino for the direction, pulse and enabled. You will see it in my Arduino code. And if the voltage is less than 12 volts for an Arduino Nano or Mega or Uno, in my case I use only 9 volt, 9 volt is less than 12 volt. You can use the DC plus to connect with the V in and the DC minus with ground for Arduino. And I also used a switch for DC plus and V in to disconnect DC plus and V in when I connect my Arduino to my PC, because I don't want to damage something. And when Arduino is connected to a PC, I don't need a power supply. And then the current I choose 2.14 amps, so I can switch the dip on off, and I used the micro stepping with 64 micro steps, and I can switch SV5 on, SV6 off, and SV7 off. And that's all. The connection is very simple.